Hi everyone, welcome to my channel. So in today's discussion, we'll mainly discuss about some of the basic SDET interview screening questions. So SDET means Software Development Engineering Test. So this is a purely developmental role for the QA, and you should be knowing some of the basic concepts, not just QA, but overall networking and little bit of development also. So let's talk about the questions. So these are some of the basic questions which you can expect during the screening stage. Like if the CPU and memory usage in the production environment is very high, what actions you will take? Next question is, what is the difference between TCP and UDP? Next question is, what is the difference between connection timeout and socket timeout? What is just-in-time compiling? What is message queue and queue date? What is the difference between hash map and hash table? And what is deadlock in database? These few questions, as you can see, some of the questions are related to networking, let's say TCP, UDP. Few questions are related to programming, hash map, hash table, URL database. Okay. So expectation is an SDET should be knowing not just manual testing, automation testing. You should be well aware of the networking concepts also. So to clear the interview basically. Now we'll talk in details about these questions in the next slides. So first question is, if the CPU and memory usage in the production environment is very high, what actions you will take? So basic um, actions what you will take is to identify the costs, like how much is the CPU and memory usage, and this can be done through task manager in the Windows and by using some commands like top and htop and pa in Linux, and you can also check the application system server logs. So in the Windows Task Manager, you can see like which process is consuming more CPU usage. You can basically go for end task. You can close that task, and you can basically reduce the CPU memory usage. Similarly, you can also move to the service section and see which service is consuming more memory, right? You can basically close that service. Okay, and so next is you can take quick remedial actions, like you can restart any high consuming services, and you can terminate any rogue processes which is consuming more memory. So next is you can also analyze application performance. For example, if there is any memory leakage, you can basically check through any appropriate softwares, optimize database queries. So some of the databases would be like SQL, Postgres, MongoDB. You can fine tune your queries to see if that's not causing any performance issue or indexing issue. So you can optimize the database queries to make sure that performance is up to the mark. Optimize resource usage. That this can be done by increasing the resources. Let's say if somebody is working in AWS, he can basically spin up an instance and modify an instance by increasing the CPU and RAM resources in the EC2 instance, and there is option of load balancing also by increasing more number of instances in the cloud. Most of the cloud providers, they actually allow the users to increasing the load balancing and increasing the resources. Also, you can basically use a cache optimization technique to reduce the load on CPU and memory. Long-term solutions will be to ensure these areas can be looked into, what is code optimization, database optimization, scalability planning, update software, and regular monitoring. So these areas should be looked into to make sure the long-term solutions on high memory usage can be resolved. So we'll move to the next slide now. What is the difference between a TCP and UDP? TCP is a term stands for Transmission Control Protocol. It is widely used in networking. It establishes a connection between sender and receiver before data transmission begins. It is a connection-oriented, reliable, and ensures data integrity with mechanisms like acknowledgement, flow control, and error checking. It is crucial for application where data accuracy and order is crucial. What is UDP? User Datagram Protocol. It is connectionless, less reliable, but faster with lower overhead due to its minimalistic approach. It is suitable for applications where speed is prioritized over reliability and some data loss is acceptable. So the major difference is TCP establishes a connection while UDP is connectionless and it is more faster with lower overhead. Most of the cyber cafes you might have came across the concept of transfer control protocol so that connection can be spread to the multiple systems through TCP. What is the difference between connection timeout and socket timeout? This is one of the questions that can be asked during the screening process. So connection timeout is basically a process that happens during the initial connection establishment, and basic purpose is to limit wait time to establish the connection, and scope is to initial handshake phase, and configuration is to client side it's basically done for the client side at the initial connection level. So there should be a connection timeout to make sure that connection should happen during that period of time, and if it doesn't happen it should basically time out the connection. And next is socket timeout. This happens during the data transmission after connection is established. So this is basically during the process your connection is established and when data is in transmission stage. Basic purpose is to limit wait time or read and write operations, and scope is establishing connection phase. Configuration is socket level or read and write operations. So understanding these timeouts is crucial for configuring network application to ensure that they handle network delays and server unresponsiveness appropriately. So in both these timeouts, connection and socket timeout, you should be getting an appropriate error message if system is not responding. And this is one of the questions that a tester should expect for an SDET role, and this is related to networking. Next question is, what is just-in-time compiling? Just-in-time compiling is a runtime compilation technique used in various programming environments to improve the performance of interpreted programs. Instead of compiling the entire program before execution, as in ahead of time compilation, JIT compiles code just executed before it is executed. This approaches combines the advantages of both interpretation and compilation. Now, some of the compilers can be like Java Virtual Machine, JVM, .NET Common Language Runtime, CLR, JavaScript engines like V8 in Chrome, SpiderMonkey in Firefox. So, just-in-time compilation is basically a compilation that happens during runtime. Okay, and it has some advantages because it compiles the code before it gets executed, and if compilation fails the code will not execute at all, and you should be able to see the compilation error. Next question is, what is message queue and queue date? Message queue is a system that allows asynchronous communication between different components by storing and managing messages. It decouples the producer and consumer, ensuring reliable message delivery and facilitating load balancing and scalability. So some of the examples of message queue systems are using RabbitQueue, Apache Kafka, Amazon SQS. So RabbitQ is basically an open source message broker that supports multiple messaging protocols. Apache Kafka is a distributed streaming platform that is used for building real-time data pipelines and streaming applications. Amazon Simple Queue Service is a fully managed messaging queue service provided by AWS. And next is ActiveMQ, an open source message broker written in Java that supports various messaging protocols. So these are some of the message queue system that queues a message and it's delivers the message to the customer. Queue date typically refers to a specific date associated with a message in a queue, such as by enqueue date, which helps in tracking message age and latency. It is useful in monitoring, auditing, and performance analysis in message queue systems. Though the importance of queue date is latency tracking, auditing, and monitoring and performance analysis. We'll go to the next question. What is the difference between hash map and hash table? Hash map and hash table are both part of Java collection framework and are used to store key value pairs. Choosing between hash map and hash table typically depends on whether thread swap is required and the specific use case for hash map being preferred choice for most modern application. So from the difference you can understand both are like a part of Java collection framework and they store key value pairs. So the advantage is like if you want to verify a count of specific string or an array characters, you can easily use like hash map concept. In terms of thread safety, hash map is not a thread shift and requires external synchronization of concurrent access. Hash table is thread safe and built in synchronization. Null handling, hash map allows null keys and values. Hash table does not allow null values and keys. Performance, hash map is generally faster due to lack of synchronization overhead. Hash table is slower due to synchronization. Usage and legacy, hash map is a part of modern Java collection framework and is preferred for new code. Hash table is a legacy class and is generally avoided in favor of hash map or concurrent hash map. Inheritance, hash map extends abstract map, hash table extends dictionary. Iterators, hash map iterators are fail fast. Hash table enumerators are not fail fast but iterators recommended. So we'll move to the next question. What is a deadlock in database? Deadlock is a situation where two or more transactions are unable to proceed because each is waiting for the other to release a lock. Detection done using techniques like wait for graphs to find cycles indicating deadlocks. Resolution typically involves rolling back one or more transactions to break the cycle. Prevention techniques include lock ordering, timeouts, and deadlock avoidance algorithms. So understanding and managing deadlocks is crucial for ensuring the smooth and efficient operations of the database system, especially in environments with high concurrency. You can understand from deadlock line, this is a situation where two or more transactions are unable to proceed because each is waiting for other to release a lock. So these are some of the basic screening questions you can expect in an SDET role. And for all testers, as you can see the questions, these are not directly QA specific questions. There could be some network specific questions, some development specific questions you should expect. So I hope you will go through these questions and prepare accordingly. If you like this video, please hit a like button and do subscribe my channels. Thank you.